Hi everyone, my name's ElectroDonkey and today we're going to be doing the possibly last video, depending on where I decide to take it, of the AI series. So in the last video, remember we had a little bit of an issue going on, in that the first iteration almost would run, and then the second would run, but it would kind of fail, it would error before it finished. We'll see in a minute. It would get close, some would hit, and it's obviously much better than the first iteration, but then it would error like this. And the reason is because we don't actually have anything saying that we have to stop at this many directions or instructions. Now to do this, we're going to put a little if statement in the draw event, which isn't actually the most efficient way, but it's because we've got all the movement stuff here, so it makes sense to put it there. But anyway, the current step I is greater or equal to the, I forgot what we called it now. What did we call it? I'll check on here. We called it minimum steps. So we're going to do that. Is less than or equal to minimum steps plus 50, I think I said there. Yep, and steps does not equal 0. Now the reason we do steps does not equal 0 is because to start off with, our minimum steps isn't set because we haven't run an iteration yet. And that's basically, and then we're going to set that AI to being inactive, and the way we're going to do that is just saying it is not moving. And then if you remember in the step event somewhere, we had a little bit of code here saying basically if none of them are moving, then we move on to the next step, and that's how this is being run basically. So we should be able to give that a go now and see that this iteration runs. This iteration is obviously terrible at it, they're all just doing it randomly, only one or two should hit. Yeah, so one hit, and then we've got this iteration which is obviously doing better, they're more in the general direction. We're going again, obviously a lot more in the general direction now, we're getting 20s, 30s hit, and basically we could just keep this running and it would just keep going until eventually it finds the most efficient solution. For the time being though, we're going to leave that running in the background so we can come back to it, and we're going to do a little bit of draw coding. So I did mention this in the last video with the draw event here, so the steps and stuff, we did actually start doing it and then I realised it's not necessary. So we're going to do a little bit of coding there. So we're saying if this, we need an if statement there actually. Oh, we don't want that. I'm missing all my keys. What the? Right, okay. So if the steps is equal to 0, we're going to do this. In fact, we're going to do this anyway, but we'll just pull in an else because we do actually have another thing to do. We need to put if I equals 0. So this is our most efficient one of the next generation, because this is of course from generations 2 onwards. So from this one there should be a most efficient one, the one that made it there first on the last run, and that is in slot 0, in index 0. So in this scenario, index 0, we're going to draw to be green, so we can actually just copy this identically. Now there's two things you could do. You could leave this as I, you could change it to 0, it really doesn't matter. Yeah, because I is always going to be 0 anyway, so we'll leave it for the moment, it doesn't really matter. I'm going to set the colour to be green. We do actually need to do this before, which is something I don't know why I've done it here, but whatever. We're then going to set the colour back to being black, like that. So we're going to draw green with a black border. I don't know why we've set it back to white. I think that might be the default colour. So yeah, that's all we're going to do there. So it's going to highlight the one that is the best, basically. And then we're just going to copy this here. So we're just going to draw the rest in black and white. So that is pretty simple. We can probably see now it is on. It's on iteration 40. It's actually failed there, which is a shame. But it definitely shows there's work to be done. There's room for improvement. So I'll talk you through what's actually happened there. It's run. We missed a curly bracket there as well. It's run too many times almost. So it's got to the point where each time it's demanding quicker runs, and it can't get those quicker runs. So if we remember, that one landed right there. We should see the green one land also just there. Or maybe we won't, because the green one's broken. That would suggest that our adding in of the first thing isn't working properly. So we can check that. I'll full screen this. So where we add them in is here. We copy every direction over from there. It might actually be worth putting a little bit of extra code in. So it isn't essential, but it makes it much nicer. So we'll do that now, which is probably causing it, so it'll be worth it anyway. It's another little check, so we'll just comment that there. I put it as a separate block, but it wasn't really big enough for it to be warranted for this one. So we're going to use that one, which loops through all of our indexes, that for loop. Then we say if final steps I, so if the steps is reached is less than or equal to minimum steps, then replace it. It's pretty simple. Whoa. Yeah, as I say, I'm missing all the keys today. I'm not really sure why. So I'm just gonna have to type slowly. So there we go. That is our final little track. So that should ensure that every time we're getting the right one copied over, which should mean that we don't get any failures like that last run. So if we think that one landed just there, so our green one should land just there. I'm wondering as well whether we've... Oh, okay. There's a classic thing here. Just a little typo. It shows that I do them as well, even when copying over almost word for word. Here we've put for var I equals 0. We actually want to start on 1 because we want to exclude the randomization from the first index, because that very first one is of course the one that is the most efficient, so the fittest AI. So the one that's most fittest, we don't want to mutate and make him completely different, because he wants to stay exactly how he is, because he's, well, got it bang on last time. Yeah, you can see there the green one did land exactly where we put our thing. So we should see now that the amount hit goes up quite rapidly. It kind of caps, I noticed, around the 60 to 80 mark. You will never... Oh, that one actually went quite high. Wait, I don't know how many... I forgot how many... Oh, we put 200 population, okay. So it should go to like 120 to 50, I think. So yeah, what you will notice is the amount hit doesn't actually go up. In fact, it sometimes go down. Sometimes, yeah, you see there it's actually gone down. It kind of varies. So that is where the next project will come in. So we're kind of finished with this set, if you would. So we have the extended project, and I'll just close it down, which actually gives us a lot more feedback, because we're not making one that hits the most 100% accurately. This has actually got a obstacle in, which we probably won't have time to do. But I'll try and demonstrate what happens. So you see the time for step 1 gets output, and every time we run it, it outputs the next time. So you should see, if we ran this same output on the other, the intelligent AI that we ran, we should see that each time it gets quicker and quicker and quicker because it's running on the same system. Except this has got a lovely little obstacle in. So you should see, and we'll add this in the next video, which will probably be the last one, a lovely little overlay like this, which gives us a bit of feedback as to whether they're doing better, whether they're doing worse. Because the amount hit is kind of irrelevant, especially on this one. This one really demonstrates it because you'll only ever see 1 or 2 get hit because it immediately skips to the next stage. So we'll probably go on to that. That's something that's quite interesting, I think. It's definitely to see the improvement, especially on the ones where it is just a straight line, because you should eventually see it hit one definite point all the time. So anyway, that was the penultimate video of the Intelligent AI series. If you like this video, remember to like, subscribe. What do you guys want to do? And I'll talk to you in the next one.